Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the components of blockchain. So, totally there are 7 components in blockchain. We'll be looking into all those components in detail in this particular video, starting with the very first component, which is the node component. Now, you can see the definition. Node is nothing but an electronic device that is a part of blockchain network and it has an IP address. Now, if you look at this particular diagram, here you can see that let's say this is a network which contains certain participants which are a part of blockchain network. Now, here you can see there are total 4 participants and each participant will be nothing but a computer. That computer will be involved in all the transactions. So you can say that this each and every single participant is nothing but a node. So this is a node, this is a node, this is a node, as well as this is a node. Now, every single node will be having an unique IP address, which will make it unique in the entire network. So, no two nodes will be having the same IP address. Now, there is one more job of a node, and it is nothing but to confirm the legality of each subsequent batch of network transactions, that is nothing but block. So in the previous video, I already told you an example in which inside the book club, we were creating blocks after every single transaction is done. Now, once a block is created, the one who is going to verify whether this particular block information is correct or not is nothing but the nodes. Each and every node will be involving in that particular verification process, and every single node will be verifying that particular block is valid or not. So this is the primary job of a node. So I hope the node component is clear to you all. If in future there is something more I have to tell you regarding nodes, then I'll surely tell you in the upcoming videos. Now, talking about the next component. Here you can see that the next component is ledger. In the previous video, we already have got a basic idea of what exactly ledger is. So now, technically what exactly it is, let's see. Blockchain is referred to as public distributed ledger technology. So there is another name for blockchain. It is nothing but public distributed ledger. Now, the term public says that the ledger or the piece of information that is present will be distributed among every single participant which is involved in that particular network of transactions. So that is why it is public. And this distributed word comes from the idea that every single participant involved in that particular pool of transactions or in that particular network will be having a copy of ledger. That means everything will be transparent among every single participant in that particular network. Now, the technical definition of blockchain ledger is it is nothing but a record keeping system. So basically, the ledger will contain records of all the transactions that has got occurred. Now, the ledger maintains participants' identities anonymously. That means here everything is going to be public, but the identity of each and every participant, or rather, each and every node, will be anonymous to everyone. Now, the ledger maintains the cryptocurrency balances in every single node's wallet. So basically, how much amount of cryptocurrencies are present and what all transaction took place with that particular wallet will be present inside the ledger. And it also keeps a record of all the genuine transactions that takes place inside the network and also between the network participants. So basically, it is nothing but a kind of sheet in which every single record will be noted. But the way in which these records are kept, it is different. Each and every node will be having its ledger copy with it. And also note one thing, let's take an example with this particular scenario. Let's say in a network we have 3 participants A, B, C. Each and every participant will be having a copy of the ledger. Now, let's say a transaction occurs between A and B. A transfers money to B. Then the ledgers that are present with A and B will be updated. At the same time, since C is also part of this particular blockchain network, C's ledger will also be updated with that particular transaction. So this is how the ledger works. It is dynamic as well as it is transparent to every single participant involved in the blockchain network. I hope this particular ledger thing is clear to you all. Now, let's move on to the next component in the blockchain component list. So, the third component is wallet. Now, by the term wallet, you might understand what exactly it is and how it would work. A blockchain wallet is a digital wallet that allows the user to store and manage their Bitcoin, Ether, and other cryptocurrencies. So, it's not about currencies, it's about cryptocurrencies. And with that, it also stores the record of transaction and also public as well as private keys which are used for performing the transactions. First, a wallet stores keys, public key and private key. These keys are actually required any transaction takes place. While any transaction taking place, the sender as well as the receiver must have some sort of public or private keys for any transaction to take place among them. So the wallet stores these keys as well as it also stores the record of transaction that occurs. That means it also stores what all transaction has taken place with this particular wallet which belongs to some node. Now you might wonder that why I didn't mention that wallet stores the cryptocurrencies because in reality, blockchain wallet doesn't store cryptocurrencies. It stores the information that is related to this particular cryptocurrencies. That means, let's say person A is having 50 ethers. Now this 50 ether won't be stored in the wallet of this person or node A. Instead, the information regarding this particular 50 ethers, from where this 50 ether came, what are all the distributions of this particular 50 ethers and what all transactions has taken place with respect to this 50 ethers that are present inside the ownership of this particular person. So that information will be stored and not the actual 50 ethers will be stored inside this particular wallet. So I hope this thing is clear to you all that wallet stores the keys as well as it stores the record of that particular cryptocurrencies as well as the transactions that takes place inside the blockchain network with respect to that particular wallet. Now let's move on to the next and the most important component, which is called as nonce. Now this particular nonce component is nothing but number used once. It's a number, a unique number you can say, which represents a particular block. Every single block will be having this nonce, a unique identity which is given to that particular block. Now, it is a random 32-bit, that means 4-byte number that miners use as a base for their hash calculations, which is adjusted by the miners. Now, there are a lot of terms involved. The first thing is miners. So basically, who are those? So miners are nothing but node. They are those nodes who choose to become a mining node. Now, a mining node is someone who mine this particular term, that is nonce, which will be the unique number to represent a particular block. Now, if a block is created, before the creation of that particular block, there are a lot of computational things that happens. One of them is the creation of this particular term nonce. So basically, the nodes who choose to become mining nodes will try to compete with each other, will try to find out this particular nonce term, that is the unique number, 32-bit number for this particular block. Now, how that particular competition occurs for finding out the nonce, we are going to look into it further. So, in summary, this nonce is nothing but that number which miners mine after performing a lot of calculations. Each block contains a nonce to ensure that the old communication cannot be reused in replay attacks. This is the most important thing a nonce is used for. Now, let's say we have the chain of blocks that are present inside the blockchain for now. And because this nonce is a unique number that is given to every single block, that is why attacker cannot claim usage of older communications. That means older block cannot come as a new block in the network because whenever a new block is created, the verification will be done and miners will assign the new nonce or I would say the unique number to the newly created block. And that is why this particular thing cannot happen. Replay attack cannot be occurred. So I hope the usage of nonce component is clear to you all. There are a lot of things to understand about nonce. In future, we are going to look into it. So for now, I hope the basic idea about nonce is clear to you all. Now, let's move on to the next component inside the blockchain component list. So the next component is hash. A hash is nothing but a mathematical function that takes an input string of any length. The length is not fixed. It can take an input of any length and it converts it into a fixed length output. This is the most important term to highlight. Now, the hash function takes input of any length and it generates a fixed length output. Now, there are a lot of advantage of this particular hash function. The very first advantage is that if we want any input to be converted into a fixed length output so that it becomes easier for us to store that particular stuff because every single field will be of fixed length. So it becomes easier. So for this one purpose, hash function is very important. Other than that, there are three properties. These properties becomes the advantage of using the hash functions. The very first property is that it is collision free. Now, collision free means let's say we have two inputs. Let's say A is our first input and B is our second input. Now, let's say we give this particular A string into the hash function and it generates an output. Similarly, if we give B to the function, it generates some output. Now, the speciality is that no two different input will be having the same output. That means whatever output this particular function having the variable a will be generating, it will be different than the other output. So every different input will be having different output. Even if you provide a as an input and in the second time you provide a as an input, in both the cases the output will be different. So I hope this thing is clear. Now, one more thing to note that if I provide an input, let's say A, first time to the hash function and it generates some output. Now in the second time also if I provide this particular input A, it is going to generate the same output because our input is same. In that particular case, it is going to print the same output. The second property of this particular hash function is that they can be hidden. That means if you are having this hash value, you cannot come back from this hash value to the input. So it is irreversible. If you know the output, you cannot compute the input. But yes, from input, you can compute the output. And that is why it becomes more secure if you use the hash term. The next property is that it is puzzle friendly. So I hope all these properties of hash function is clear to you all. Now we have understood what exactly hash function is, what is the property, and what are the advantages of using hash functions. Now let's see where this hash function is actually used. So uses of hash in blockchain technology is in Merkle tree. So this is the most important term. We are going to look into what exactly is this Merkle tree and what are the terms associated with it. For example, Merkle root. There is a lot of advantage of using this particular term in blockchain, and this is only possible with the help of hash functions. The next usage of hash function in blockchain is in chain of blocks. That means if you have this particular chain of block, let's say you have three blocks in the chain, the usage of hash function is that every single block, every single current block will be having the hash value of the previous block. And since it stores the hash value of the previous block, it becomes very simple to figure out that this particular block is belonging to the chain of transaction of this particular blockchain network. So every single block will be having the hash value of the previous block. That means this block. So this is how it goes. So this is one of the usage of hash function in blockchain. The next is in POW consensus, that is proof of work consensus algorithm. Now, proof of work consensus algorithm is something totally a different topic. We are going to look into it in a separate video. So in that also we use the hash functions. So I hope the necessity of using the hash component in blockchain is clear to you all. Now let's move on to the next component of blockchain, which is the mining component. So if you remember, in nonce component also, we addressed this particular term, mining and miner. So now in this particular component, we are looking to it in detail. So what exactly is this mining? Mining is the process of miner being rewarded for finding out the appropriate nonce first. Note this particular thing. So basically, as I said, there are going to be mining nodes who will mine the nonce. So let's say we have A, B, C, D as the miners, or I would say they are the mining nodes who are going to find out the nonce. So all these nodes will be competing with each other. So they will act as if they are competitor and they will try to compete with each other for what? To find out this particular special term that is called as nonce, or it is also called as golden nonce. Now let's say the mining node C got this particular golden nonce first. So in this particular case, this the mining node C will be rewarded with 12.5 bitcoins. So 12.5 bitcoins will be gifted to this particular node C since it found out the nonce first. And since it found out the nonce first, this particular node, this particular mining node will be responsible to add the block to the blockchain. This is the newly created block with the new nonce that was found out by the node C, and it is added in the blockchain just because of this particular mining node who is getting a reward of 12.5 bitcoins. And a successful verification is the only way the bitcoins get added to the network. Now, let me tell you the process of finding out the nonce in short. So, every single mining node will try to find out a random number. Now, what exactly that random number is? It is nothing but nonce, and it is going to be a 32-bit number. So, this this nonce will be randomly generated number by every single miner. Now, what they will do after this, once nonce is generated, they will try to hash this particular nonce number and they will get a hash output. Now, once this hash output is created, this hash output will be compared with a target number. So, this target number is already set. The hash output will be compared with this particular target number. If this particular hash output is lesser than or equal to this target number, then this particular nonce is going to be accepted. If not, then this particular nonce is rejected and an incremental operation will be done and another random number will be generated. Again, this particular process will go on. The random number will be hashed. It will create a hash output and this hash output will be compared with the target. If the hash output is lesser than or equal to the target, then it will be accepted. Otherwise, it will be incremented. So this is how the process goes, and whichever node finds out the correct nonce first will be rewarded with this particular set of bitcoins. So I hope the process is clear. And also, there is a speciality. Whichever mining node is rewarded with this 12.5 bitcoins, after 4 years, let's say this node C has got reward of 12.5 bitcoins because it mined that particular nonce first. So after 4 years, that particular 12.5 bitcoins will be reduced by half. So after 4 years, the Bitcoin will be 6.25 and it will go on and on. After every 4 years, the Bitcoins will be reduced by half. So this is the speciality, or I would say this is the term that you should understand and keep in mind. So I hope the entire process of mining is clear to you all. This is a major component in the blockchain component list. So I hope it is clear. Now let's move on to the next component and the last component inside the blockchain component list, which is the consensus. So this consensus is nothing but it is a procedure in which peers that are involved in the blockchain network will reach to an agreement about the present state of the data in the network. Now, in the previous video, I already said that whoever is involved inside the blockchain network, every single peer will try to verify the transaction that takes place. Now, for verification, there must be some algorithm that has to be used by every single peer so that a basic uniformness will be maintained. And that algorithm is nothing but it is consensus algorithm. Now, there are a lot of consensus algorithms that are present inside blockchain. One of them is POW that we have encountered previously, that is proof of work. The next is proof of stake, then proof of activity, proof of capacity. There are a lot of consensus algorithm. We are going to look into the most important ones in detail in the upcoming videos. So I hope this particular consensus component is also clear to you all. The main aim of using this consensus algorithm is to establish reliability and trust among all the peers that are involved in the blockchain network, as well as making the network trustworthy. So I hope this is clear. And with this, we come to an end to this particular video. I hope every single component inside the blockchain component list is clear to you all. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. And if you have any doubts, please comment it down. Thanks for watching and have a good day ahead.